Welcome to Tableau. So I am here talking to you on the research track about some of the work we're doing on recommendation systems at Tableau. And I want to pull Robert up here first too, because we're going to be doing this presentation together, and I'm going to start you off and he'll finish you off. So I'm Maya. I'm a data scientist at Tableau. I've been here for about a year and a half, so this is my very first TC ever. And I've been working on recommendation systems, so that's what I'm going to talk to you about.
And I'm Robert Kincaid, and I'm from Tableau Research.
Great, okay. So I'll kick you off then. So I'm going to start by talking about just telling you what is a recommendation system and why we might actually want one of those at Tableau. All right, I have a clicker. Hold on a second. High tech. And because this is a research sort of focused talk, we're going to talk a little bit in more detail about what types of recommender systems, how one might build a recommender system. And the two types that we'll focus on are collaborative filtering, which is the basis for our upcoming, or actually I guess it's already released, 2019.4 View Recommendations feature in Tableau Server and Tableau Online. And then content-based recommendations, which is what Robert is going to talk to you about later. So I'll talk to you about how we actually built this feature and how we want to proceed after. And then Robert will talk about some of the research we're doing into content-based recommender systems. But first, so why am I actually talking to you about recommendation systems at Tableau? And our customers are facing a really, really common problem. They're absolutely drowning in content. So the largest deployment that I know of has over 1 million Vizzes. So how are our users actually supposed to find the information that they need in order to do their jobs? And in some ways, we're victims of our own success. So we've created this dynamic self-service environment, and users are creating amazing content much faster than conventional curation and data share and knowledge sharing can actually keep up. So what we found in our user research is that the main way that users find new content now is through peer recommendations. So their colleagues at work will send them Vizzes over Slack, essentially. And what we wanted to do was something slightly better. So we're hoping that by using machine learning, we can actually provide these recommendations even better, so recommendations that are based on each user's individual tastes. And so what is a recommender system? And whether you know it or not, you are all familiar with recommender systems. So all of these companies up here, do we have any representatives of these companies in the audience? No? Okay. All right. All of these companies up here on the surface are very different, right? So we've got some media companies, we've got some online shopping, we've got ad placement, we have a dating service. But what they all really have in common is that they provide value to their users by dealing with this information overload problem. So they have immense stores of content, and they provide a shorter subset of this to their users in order to surface only those things that they might actually want to look at. So in some sense, this is what a recommendation system is. It's an information filtering system that predicts the preference of a user for an item. But that's pretty dry. I actually like to think that recommendation systems are so much more. They're an engine for discovery. So I like this quote a lot. It says, "Search is what you do when you're looking for something. Discovery is when something wonderful that you didn't know existed or didn't know how to ask for finds you." And this is really what a good recommendation system does. It's those moments of serendipity that we're looking for. So because this is a research talk, we'll go into more detail. So how do you actually build one of these recommendation systems? And there's two main types of recommendation system based primarily on the type of data that you want to use to train your models. And I'm going to explain through an example, okay? So let's just say that I've just watched the cult classic cybercrime movie Hackers. And I have two different recommendation systems. So my content-based recommendation system knows everything about the movie Hackers. It knows the actor and the director. It has expert reviews. It has Rotten Tomatoes. And it tries to recommend to me items based on this metadata. So in this case, our recommender notices that the lead actress is Angelina Jolie, and it recommends to me other movies with Angelina Jolie that are starring Angelina Jolie. Collaborative filtering, on the other hand, doesn't know anything at all about the movie Hackers. In fact, it doesn't even know that it's a movie recommender. So it bases its recommendations by mining the patterns of user-item interactions. That is, which users watched which items or which movies. And this works because of the simple fact that tastes are correlated. So if Robert and I have watched many of the same movies, it likely means that we have the same taste in movies. So I could do a good job of recommending movies to Robert. So in this case, our recommender notices that people who watched Hackers also watched these other 90s cybercrime movies, even though they have none of the same metadata at all. So which approach to choose? So part of it is which data you have available to you. And really the advantages and disadvantages of these two different methods are completely complementary. So one of the biggest advantages of content-based recommender systems, and conversely, one of the biggest disadvantages of collaborative filtering recommenders, is how do you recommend new items in your repertoire? And so for content-based recommenders, as long as somebody has actually collected the metadata, so knows about the actors and things like that, then you can easily recommend them as soon as they're actually added to your database. Whereas with collaborative filtering, the data that it's training on is the usage data. And if no one has seen this movie yet, it has no idea how to recommend it to you or not. And this is actually a really big deal, especially in places where the amount of content is constantly increasing, where you're constantly getting new items. So for instance, like news recommenders. The second advantage of content-based recommenders is it can provide ready, intuitive explanations for why it's recommended me things. So as an example, Pandora is a music recommender, and it has a content-based recommender model in it. And so when it recommends to me a song, it can say, that's because I know that you like punk rock with female vocalists. So the collaborative filtering algorithm would probably learn that I also learned that I like that song, but it would have no intuitive way of explaining why I like that song. On the other hand, the disadvantage of content-based recommenders is that you actually need somebody to gather that metadata. You need to have the metadata in order to train with. So collaborative filtering models typically require less training data to start with, but from that data, it can actually learn really, really rich patterns in the usage data. And it actually tends to provide more in the way of serendipity. So those moments where you get something that you didn't expect rather than something that you could search for yourself. So for those reasons, when you first build a recommendation system, collaborative filtering is usually a really good way to start. So it's usually your first good bet for a recommendation system. And so that's why we used that for our upcoming release of view recommendations. And of course, there is one other option, which is don't choose at all. So you can actually, it's a very common practice in machine learning to ensemble different models, to combine different models in order to get the best of both worlds. And so you can quite easily combine a content-based or a collaborative filtering recommendation system in order to get the best of both worlds. So like I said, I'm going to start talking to you just a little bit more about the models involved in collaborative filtering, and specifically which ones we're actually using for our collaborative filtering model for our view recommendations. So the very first and easiest collaborative filtering model is just to measure the popularity and recommend to people things that are popular. And this is actually extremely successful, because if things are popular, that means a lot of people are going to like them. But of course, this isn't personalized at all. So and the personalization is really, really where the magic is. The next level where you start to increase the personalization is what's called a neighborhood model. So essentially what this is doing is that your algorithm is searching through all the users for users that have the same taste as you, that have watched the same movies or read the same books. And so once it's found those similar users to you in terms of taste, then it simply recommends to you items from those users that you haven't seen before. So this is actually really similar to what we use today in Tableau, which is peer recommendations, except that in this case, the algorithm finds the peers for you. So the method we actually use for personalization is what's called a latent factor model. And so for this, let's go back to the example of a movie recommender. So the data that we actually have to train on is a ratings matrix. So whenever a user rates a movie, then we get that rating as an element of the matrix. And so in this case, Alice here really liked Spider-Man and didn't really like the Matrix. And Bob, he loved the Matrix, but kind of thought that Mad Max was overhyped. And so you get the idea. And so obviously not every user has rated every movie, and so those are the question marks, and those are really the things that we're interested in. Should we recommend Mad Max to Alice or not? And the way that we do this, the way that we do this is that we take this ratings matrix and we factorize it into the product of two smaller matrices. So that's the item factors and the user factors. And when you multiply these two matrices together, then it tries to approximate the ratings where they exist, but everywhere where there's a question mark, it actually fills in those blanks for us. And so those give us scores with which to use to recommend items to new items to users. So to be more specific, so each item is now represented by a vector of, figuring this out, a small vector of numbers. So a small vector of item factors, and each user is now represented in our model by a short vector of user factors. And so when you take the dot product of those two vectors, that is the score for each user item combination. So you can combine any user item combination by dot producting the item factors with the user factors. And by using smaller matrices, what we're actually doing is we are losing some of the detail. So we're losing some of the detail of the original matrix, but we're compressing the data essentially and forcing it to generalize and find general patterns in the data. So general patterns of user tastes. So very observant people in the audience will have noticed that there is absolutely no way right now to rate your viz in Tableau. So we don't have ratings like I showed you before. So what we actually have instead of ratings is what we call implicit feedback. So that's the click logs. So the data that we actually train on isn't your rating, but how many times you've actually seen each item. And so we have to infer whether you like something by how many times you've seen it, rather than letting you give us that information directly. So this is a big plot, but bear with me for a second. So what actually are these factors anyway? So they're not actually just a convenient mathematical device. They actually have real meaning. These are learned features which can be used to classify different items and different users. So what you're seeing in this plot is a two-dimensional representation of all of the item factors for each viz. So each dot here represents a visualization, a dashboard or something like that. And what you're seeing in the colors is the project that they belong to. So this is for our very own internal Tableau server. And so the thing that I want you to notice is that the colors are all glommed together. So what that means is that things that are close together in factor space are actually, you often belong to the same project. So what this means is that the factors in this case have learned about projects. They've learned that Vizzes from from the same project are similar, even though we haven't actually put the project metadata in there anyways. This is something that is actually just extracted from the pattern of user item interactions. And so there's one more complication. So we actually found that we got better results when we combined this, the latent factor model that I showed you a second ago with a variant of the completely non-personalized popularity model that I showed you before at the very beginning. So we use a trending model, which is the popularity over the last week. And the reason that we do this is that it prevents us from recommending stale Vizzes. So it turns out that Viz popularity is extremely time dependent. And this is obvious to probably all of you guys using Vizzes every day, but as developers, it was a bit of a surprise to us. So there are some Vizzes that are popular all the time, And we want to make sure that we're always recommending these things. But there are a lot of Vizzes that maybe were important a quarter ago, but they're not very important anymore. So by hybridizing, by combining these two collaborative filtering models, we actually managed to bias towards more recently viewed items. And this actually solved another problem that we had, which is how do we recommend things to new users. So this is exactly the same as the cold start problem that I showed you before, where collaborative filtering recommenders have difficulty recommending new items to users. So we also, if a user has no usage yet, so they're a brand new user on Tableau server, then we actually have no data on them, so we don't know how to recommend items to them. So in this case, new users get only the trending recommendations, so they'll see the things that are popular on their site. So I've showed you a bunch of different models, and the truth is that there's a lot of sort of pre-built canned models that you can use to do recommendations these days. And so a lot of the science in data science is actually being able to evaluate your models and choose which ones are actually right for the job. So that's what I want to talk to you about now. So we start evaluating our models right at the very, very beginning. Long before we show any recommendations to users, we want to know, is our model good or not? And so the way we do this first in the prototyping phase is we use what's called offline metrics. And so that is the best approximation of model accuracy and utility that we can get while using only historical click data. So this is long before the actual feature is actually presented to users. So once again, we have the number of times each person is viewed, and these zeros are now sort of the equivalent of question marks in the previous case. So 0 actually could mean that a user doesn't really like that viz, but more often it actually means that they just don't even know it exists. And so we have our usage matrix, and what we do in order to evaluate our model is we split these view events into training data and test data. And what that means is that we take out some of those views, the grayed out ones that you have there, and we pretend we don't know about them when we're training. So we train on all of the black ones, we train on all of these historical views, but then we hold out this test data and we're trying to predict those things. So we're trying to predict things that users have actually already seen. And one of the important things that we learned when we were learning about this freshness or staleness issue is that it's very, very important that those test views come from the latest data that's available. So the latest, the things that people have discovered most recently. And so the first thing that we want to measure with this is a precision, and that's a measure of the model accuracy. So if we provide 5 recommendations, how many of those recommendations are actually in that test set? How many of them were actually viewed by the user? The second part, we want to make sure that our product is as useful to as many people on Tableau as possible. And so we want to make sure that, that all these users are getting utility. So the user coverage is how many users got at least one good recommendations in their recommendation set. And so our observant audience member will have noticed in this case that I have crossed off all of the women on this slide right here. And so this is actually a really big problem in recommender systems, is that they tend to recommend for the majority. And so they can actually exhibit a lot of bias. We want to make sure that our recommendation system, again, really covers, doesn't exclude entire categories of people, of users. And so in our case, the important category of user is really, so it could be people on smaller sites, like different than the normal type. It could be new users, that's a really big deal. So we really want to slice and dice our data in as many ways as possible to make sure that we're hitting our targets for as many users as possible. So those offline metrics, while they are the best we can do with historical data, are really imperfect proxies for feature quality. So there's no substitution for actually asking users what they like and what they don't like. So in our previous example, I could have gotten 100% marks. I could have gotten an A+ by only recommending to users things that they could already find by themselves. And so that would obviously be a pretty poor recommender. So what do we do instead? So before we deployed, we did extensive user research. And so for us, that was surveys and interviews where we gathered explicit feedback, there's that word again, on when users were actually interacting with our prototype features. And so this is actually an example of something that we did. So we presented Tableau users. So actually, I guess they were Tableau devs. So they were internal users of our Tableau server with their recommendations. We presented them with 10 recommendations, and we asked them how many or which ones were useful and which ones weren't useful. And so what you're seeing here is that about 50% of the Vizzes were useful to users on average. So, but on the other hand, we actually are doing much less well for new users. And so we knew that this is a problem. We have much less data about them, and we're only giving them trending Vizzes. But this is something that we think is important. How do we onboard new users to Tableau using recommendations? So now that we're released in 2019.4, a couple weeks ago, we can actually do even better, where we collect implicit feedback, again, that's the clicks, from user interactions with the released features. So which recommendations did people click on? Which of them did they favorite? Which ones did they actually like? And so from that, we can actually start to gather statistics called online metrics. And these are much better, they more directly measure business goals like user satisfaction. So they're things like the daily active users. So how many people come to recommendations every day? How many people come back over and over again? How many people came for a while and then stopped? So these are really important ways of measuring how people actually like our feature. Additionally, we can run experiments on online only with different models on live recommenders. So certain subsets of users can get different models, and we can decide which one of them are better. So that's called A/B testing. And of course, now that we have those statistics, it's great, but it actually often takes these surveys. We have to go back to the surveys and interviews in order to figure out what do these statistics mean. So people are leaving recommendations. There are lots of lapsed users. Why is that? And so we'll be going back and doing more interviews, hopefully with actual real users of recommendations, to get that feedback soon. And so the last thing I wanted to talk to you about the models is that accuracy really isn't the only thing that's interesting about recommendations. How and when recommendations are presented to users affects their utility. Are the recommendations trustworthy? So first of all, trustworthiness is a complicated thing, but if the recommendations are good, then people will start to trust that the recommendations are good. But we know that it actually takes a lot of time and investment to actually look into a Viz and figure out if it's useful to you or not. And so additionally, we want to make sure that we give you as much context as possible to know whether you want to sink in that time investment and investigate further. So you'll see later that every recommendation comes with its own explanation to try to tell you why we're recommending it to you. Are they annoying? If you are old enough, you'll recognize this guy. So Clippy is the world's most irritating assistant, but I think it's really worthwhile to think about why he was so annoying. The reason that Clippy was so annoying is that he would interrupt your work with suggestions when you didn't need them. And so here at Tableau, we believe strongly in the flow of analysis, and we didn't want to do anything that would rob that of that integrity. Are we showing enough diversity of items? So this is another problem that recommendations have. It's just inherent to recommendation systems. Once we start showing you recommendations, you are more likely to see them, and you're more likely to interact with them. So basically, recommendation systems change user behavior. And if we're not careful, we can continue to show you the same sorts of things, and because you keep clicking on them, then we become more and more confident that that's the stuff you really like, and we don't show you anything else. So it's very important, in addition to accuracy, to promote diversity of items. And of course, data security. So that's paramount to everything that we do. We only train on one site's data at a time, and you will never, ever see a recommendation that you do not have permission to actually view. And finally, privacy. So we know that recommendations can be kind of creepy. So essentially what's happening is we're monitoring your usage in the product. That's how we do this. And so we want to make sure that people that are privacy sensitive have the ability to turn this off. And I really want to stress that none of your data will ever leave your server. even your historical, the historical event data, the click logs and things like that, that all still stays on your server. So there should be no privacy leakages. So finally, in the last couple of minutes, I want to show you some personalized view recommendations in Tableau. So this is a sneak peek into our feature. What you're seeing right here are my personal recommendations on our internal Tableau server. And you can get to it on either the little red box there shows you the left nav. We now have our left nav, which has a little light bulb. And it's also got a shelf on the new homepage on server. So if you visit the homepage, then you should be able to see these. Those little icons that you're seeing here tell you, I told you that we hybridize a popularity model, a trending model, and a personalized model in order to give you your total score for your recommendations. So what these little icons tell you is which of those models was more dominant. So is this primarily being recommended to you because it's trending on your site, or because we think that you specifically are really going to like it? We show you the title, how many people have seen it, how many people have favorited it. We show you the modified date, the owner, and also a small explanation of why you're being recommended this specific view. And so in this case, I know that I am being recommended this view because my colleagues, Connie, Yogesh, and Lou, have been looking at it recently. And finally, I want to finish up by thanking the entire team. So this was a team effort. We are a bunch of full stack developers and data scientists, and especially Eric Brochu, because I liberally cannibalized his talks to make my own. And thank you very much. I'm going to turn it over to Robert.
Oh, thanks, Maya. Maya's just shown you how recommendation systems can be made using collaborative filtering. At Tableau Research, we've been busy thinking hard about how to use Viz and workbook content to build a content-based recommendation system. I want to stress at this point that our work is still at a research stage, and what I'm going to describe is our journey through that process. This work may or may not ever appear in a Tableau product, but we certainly hope so. And I hope you'll find the journey that we take and some of the questions and issues that we raise at least interesting. First, let me introduce the research team itself. A lot of the work is being done by Michael Opperman, who is a PhD candidate at the University of British Columbia. And he's been working as a Tableau intern since the summer. His PhD advisor is also contributing insight and help in this, Tamara Munzner. She's also at UBC. And then, of course, myself, Robert Kincaid, at Tableau Research in Palo Alto. And, of course, we're working closely with our Tableau collaborators in Vancouver, Maya Warren, Eric Brochu, and Kazem. We stay in touch with them frequently to make sure that we're both sort of working in the same direction. So what does content-based recommendations mean for Tableau? Well, at a sort of basic level, what we're talking about is recommending relevant items based on comparing the item content with corresponding content-based user profile. The key word here is content. So something that describes the Vizzes and workbooks that we can compare between these two. This raises three main questions that we want to answer. First, what content is it that we're going to analyze? Where do we get this content? What kind of content is it? You can see the visual of a workbook or a work dashboard or an individual worksheet, but where do you get the content that's represented there, and how do you use that in some computational way, because you can't just base it off the image. Second, how do we want to construct the user profile that we're going to use to compare to all these individual Vizzes and workbooks? And finally, how do you even make the comparisons once you have the content? So you have some content that somehow describes the Viz. What do you do computationally that's going to compare those two in some reasonably efficient way that you can use those to develop a recommendation system? So let's start talking about how we want to make comparisons. So the basic assumption that we're making at the moment is that we can measure relevance as similarity, with the sort of insight that if visualizations look similar, they're probably some somehow relevant to you to see. And the way we're going to do this is that we're going to leverage term-based document similarity measures. There's a vast body of research and work that's been out there for decades that is used commonly for comparing two text documents. So if you had a Word document and you were searching for things that were similar to that Word document, you could take the text out of that document and make comparisons to all other documents you're interested in, and then find which documents are similar. And there's techniques that people have developed for doing that sort of thing. So we want to try to do the same thing with Vizzes. Typically, one analyzes things like term occurrence, word occurrence, and maybe word frequency. And this doesn't necessarily require deep natural language processing. So typically what we're looking at is just the occurrence of the word and maybe how many times it occurs. But we're not looking at sort of complex semantics or trying to understand what the content actually means. And so the key thing is that we're going to extract these terms from Tableau Viz specifications. So if you're familiar with the sort of desktop version, you've seen TWB and TWBX files, which we sometimes call TWB and TWBX. And the interesting thing is that those are, well, the TWB files are actually just XML specification of the Viz. And so we can dig into that a little bit and extract out some relevant terms and use those. And also, in addition, we can use whatever additional metadata that we might have, things like when the document was created and who the author is and whatever keywords they might have associated with it. And eventually we'll get around to that, but right now we're sort of concentrating on just understanding how to do this text-based analysis between Vizzes. So let me start with a very simple example just to give you a feeling for this. If you're a quant or a data scientist, you're probably going to be bored. You've seen this a million times. But for those of you that haven't, you might find it helpful to sort of work through a very simple example of this. And so one of the simplest ways to compare text is using something called the Jaccard index. And the mathematical formulation is there in the upper right. And it simply states that you're basically counting the number of words that intersects between two documents and dividing it by the total number of words in that document. And in this case, we're doing it with unique occurrences so that we're not overcounting something that happens to be more frequently. Pictorially at the bottom, you can kind of see this, that we're basically taking the intersection and dividing it by the union. So it's a very simple thing. And the examples on the right, there's two sentences A and B here. A is this is a simple sentence, and B is this is also a simple sentence. So there's a lot of words in common there. And if you work through the unique words that occur, you find out that there's 5 unique words out of 6 unique words total, and that gives you a Jaccard index of 0.83. And one of the nice features about the Jaccard index is that it varies from 0 to 1. So this is getting closer to 1, so they're fairly similar. Sentence C is this isn't like the other two, and the only common word it has with A is this. And so in that case, the Jaccard index is 1 unique word out of 10 total, and you get a score of 0.1. So it's not very similar. So you can see that we can just take the text of these two sentences and make some comparisons and compute a score that we can use to kind of discriminate between things that are somewhat similar and things that aren't. And so we're going to basically employ the same technique with Viz specifications, although it's not as straightforward as you might think. So on the left, we have a bar graph, and on the right is a snippet of the XML that specifies that specific bar graph. And I've highlighted in bold some specific terms that we're going to pull out of this. So we're going to try to capture the fact that the mark type is bar. It's being colored by category with no aggregation. And the row shelf has sum of sales, and the column shelf has region unaggregated. And those are the key things. There's a lot of other stuff in there that we don't really care about because they're not terribly informative in terms of comparing. Some things occur all the time. The basic tags we don't care about. We don't want view and not view, those kinds of things. So one of the tricky parts about doing this is figuring out what tags we need to pull out of it. So here's 3 examples. two bar graphs and a pie chart. And if we look at bar graph A, you can see the words that we created out of the specifications before. And in some cases, well, I'm concatenating these in order to make a more descriptive word out of it, and use that as being a little bit more informative. And if we compare A to B, we find that there's four terms in common out of 6 terms total, and we get a Jaccard index of 0.67, which says that it's more or less similar. And looking at it, you would say that that's probably true. They're more or less similar. But if we compare B to C, then we only get 1 term out of 10 again, and it's only a 0.1 score. And so just as we would expect, those are not as similar. And the Jaccard score reflects that. Now, the interesting thing is that this is strictly based on the visual parts of it, and we'll get to that issue in a minute. So I hope that this gives you kind of just a simple, kind of simplified view of how you can take text out of the Viz specifications and turn it into something that you can compute similarity with. Now, of course, we can use lots of other more advanced techniques, which is what we're investigating, ways in which we can do that. Some other tools that we have in our toolbox is that we can do something called stemming, where we derive the root form of a word. So indexing becomes index and booked becomes book. And you can pull off suffixes and do other kinds of manipulations to try to make really semantically similar words equivalent, so that when you do the counting, you get that right. There's also a notion of stop words, where you're basically trying to remove non-informative words. So for a simple sentence like the quick brown fox, you would remove the, because it doesn't really add any semantic content for comparison purposes, because the would occur everywhere. There's other similarity measures. In fact, we're using other similarity measures than the Jaccard, although we have used Jaccard in a few instances. But there's things that go by the name cosine similarity or Euclidean distance and other kinds of advanced methods. So I don't want to leave you with the impression that we're basing everything on Jaccard score. But so we're looking into all of those to see what's the optimum thing. And then finally, there's a really more advanced concept called term frequency, inverse document frequency. And for time reasons, I can't really go into any of these things in too much detail. But in this case, basically what you do is you normalize the term counts for their frequency of occurrence. So another thing I forgot to mention is that the cosine and Euclidean scores enable you to be able to look at the number of times a word occurs and factor that into the computation. And so that can sometimes be more informative than what I was doing with the Jaccard score. And the term frequency, inverse document frequency, is another way to even further normalize things for very rare words that might be quite informative and useful. And you weight those a little heavier than you do more common words that you might pick up. And in some ways it does something similar to what stop words does, but in a more computational way. So what does it really mean to be similar? So one thing is, the sort of obvious thing that people notice immediately is that there's visual similarity. And for doing this, we assess chart types and visual appearance. So is it a bar graph? Is it a map? What are the colors? Those kinds of visual attributes. And it's based primarily on visual encodings. Another possibility is topic similarity, where you assess the data and the analytical tasks, and you base that on the data source field names, text annotations, titles, where you kind of try to bring out some of the semantics behind the viz. And what we found was that we really needed to treat these two things separately, because they're sort of associated with completely different tasks that people might want to be doing. Am I doing it? Yeah. So I'll show you a little bit about the research prototype that Michael developed over the summer, and we're continuing to iterate on this and make further advancements, but this is kind of what we had at the end of the summer. Stress that the initial trials we were doing with this prototype was with Tableau public data, because it's a very large repository. And we used it to explore and evaluate the relevance ranking schemes that we were developing. And one of the other things that we wanted to do with this was to prototype secondary semantic filters. I'll show you one of them, but and talk about the other. But once you've gotten some recommendations, then you can further filter them by the topic that you're specifically interested in or by a specific chart type. So as you're looking at this display on the right, what you're initially presented with is a number of thumbnails based on some query that you typed in, and in this case, I typed in cats. And then I got a bunch of Vizzes that are related to comparing cats and dogs, and if you've been on Tableau Public, you might have seen those Vizzes at some point in time. Now, on the right-hand panel is the part that controls sort of manipulating the recommendations themselves. And if we take a look at that in detail, one of the things that's interesting is at the top, we can kind of specify what mix we want between topic versus visual similarity and balance those out in terms of how they're going to get averaged together. And the color coding is going to be that the orange or goldish color is for Vizzes and the blue is for topic. Sorry. And then there's some details in metadata down below to just kind of inform us about what we're looking at. So as we're trying to decide whether we're doing the right thing, we can use that as a guide. And then there's a thumbnail of the Viz at the bottom. But the real key is that if you click on the button here, then it's going to go out and find similar Vizzes to this one. So in a way, this is kind of a query by example. And I should reiterate strongly that this is a research tool that we're using. This isn't meant to be the final user interface that we would expect a user to be using, but just something that we're using at the moment as the research progresses to sort of understand whether the computational schemes are working correctly and whether it's useful in giving us good recommendations. So we click on that button, and now we're going to get an array of similar Vizzes. And right away you see that one of the problems we run into is that it starts finding duplicates because those are exact matches and it looks really good. At the bottom you'll see little bar graphs, and the blue bar graph is the averaging between the topic and similarity measures. And then the smaller blue bar graph is on that scale of 0 to 1 is the topic similarity, and then the orange is the visual similarity. And so you see with the duplicates that they're 100% equivalent in terms of topic and visual design. But if you look to the third one, you see that it's visually similar because it's a map and it's a colored map, but the blue bar graph is down around maybe 30–40% because it's not exactly the same topic based on the terms that we're extracting out. And similarly for the other two in the top row, they're all equivalent visual Vizzes, but the topic similarity is a little bit down, and so that's why they're ranked lower than the duplicates. And if you look even farther down, you'll see that the bar graphs actually have, they're not quite as similar in either one, and that makes sense because they're bar graphs, so they're sorted farther down the road. And the final map down there has very little topic similarity, even though it's visually equivalent. And we'll go back to this again as an issue that we have to worry about. Now, I mentioned that there were these secondary filters that one can do. So in this case, I've clicked on the button up at the top that says, just show me bar graphs. And so it takes that first list and filters it down to show bar graphs that are similar to the map that I just had. And so it's doing this based on how similar the Viz might be and how similar the topic might be. And in this case, the topic is pretty similar. All of these things are still about cats and dogs in some fashion, maybe with slightly different fields in them or something. And I think that the visual similarity here, even though it's not a bar graph, is primarily because it's using the same color encoding scheme. But it gives you a flavor for how you can filter that. And then the second row of buttons at the top, or pills, are various kinds of topics that we've extracted and are displayed as keywords. And you can click on a topic and filter it down the same way. So we ran into a number of challenges as we started to work through this. One challenge was that, as you saw with the duplicates, you can get multiple versions. And one of the interesting observations we made based on analyzing a large subset of Tableau Public is that it appears that approximately 10% of Tableau Public is actually based on Superstore. It was kind of a shockingly large number to me when I figured that out. And if you're not familiar with Superstore data, most people probably are, but it's a standard sampled synthetic data set of some big box store that's used for training purposes. And so there's lots of people that somehow eventually build a dashboard with Superstore data. And when people do classes, everybody builds the same dashboard and saves it out to Tableau Public. So if you happen to be working on, say you're in a class and you're working on Superstore data, and you were to ask the recommendation system to show me things that are similar to this, then chances are it's going to show you like 10,000 workbooks that are all exactly the same. And so we don't want to do that. So we have to fix that somehow. So one of the ways we're thinking about doing that is taking things that are completely identical or nearly identical and collapsing them down to one item and show that to you to let you know at least it exists, but maybe you really don't want to look at it. And then if you want to open it up and browse that in some fashion, we'd be able to support that. The other thing is to try to expose the most relevant instance as the thumbnail that you would show for that collection, so that you would, if you were to click on that thing, you would get something that was at least hopefully useful. Another challenge was this serendipity problem that Maya mentioned earlier. And this is another quote about serendipity that I like a lot, is look for something, find something else, and realize that what you found is more suited to your needs than what you thought you were looking for. And we'd really like to be able to surface those kinds of things. So some of the things we're thinking about doing here is somewhat related to the first problem, is de-emphasize exact matches, because that's certainly not going to be serendipitous. And also, we have the ability to show you different combinations of matches between visual and topic. So one of the things that's interesting about this whole visual topic thing is it's kind of task dependent. So there might be cases where you want to find, you're working with a particular data set and you want to find other ways to visualize that data set. So you don't really want to look for something that's exactly the same data with exactly the same viz you're building. You want to look for the same data, same topic, but with a different viz to see if there's another way of looking at it. And so and then you can do the other way around where you have a viz and you want to see if is there other kinds of data or other vizzes with different data that you might want to look at for design inspiration or something of that sort. So there's different tasks and combinations of whether you want to emphasize the visual or the topic aspect of it. And so that gets to be a bit of a problem. So the ability to show you different combinations of that might help give you a little bit more serendipity. And then finally, one of the biggest challenges is this whole notion of content similarity versus perception. So as I mentioned that there's these two ways of thinking about it in terms of similar viz design versus similar topic. You can have charts that have different data with exactly the same look and feel, or you can have charts that are very different but with different data. And if you were to look at the top two, you would say, oh, those are very similar, but they actually have different data in them. If you look at the bottom two, you would say, well, those are completely different. But if you look closely, it turns out that underlying that, they have exactly the same data. And so if you're looking at a ranked list of thumbnails in your recommendation system, you might just blow by the ones that don't look similar because you don't know that those are relevant. And so how do we surface that in a way that makes sense to the user? And part of the problem that's actually interesting from a research perspective is thinking in terms of what's the cognitive processes that are actually going on. So one of the insights we had recently is that perception of visual similarity is actually primarily a pre-attentive process. And this pre-attentive process is the sort of instinctive thing that you get instantly. Kind of thing that enables you to, enables our hunter-gatherer forebearers to have survived, and also enables us to play sports and all kinds of things. You don't have to think about it, you just know it when you see it. And so if you look at these two graphs, you can see immediately that they're very similar in some ways, at least. They're both bar graphs. If you look at the height of the bar graphs, they look identical. You see that there are some differences in coloring, but you see all of that instantly. And so that visual comparison is a pre-attentive thing. Whereas if you're looking for topic similarity, well, here's two completely different graphs, different Vizzes. But if you look closely, you notice that they're exactly the same data. But to do that, you actually have to read the text. And that's not a pre-attentive task. And it's also a slower task. And so it's another thing that sort of complicates this whole notion of being able to present similarity in terms of content. Because we may recommend something that's absolutely similar based on content, but you might look at it and say it's completely dissimilar. And where that's a real problem is when we try to design user studies, because you like to do these sort of A-B comparisons or ABC comparisons and say, which of these two Vizzes is similar? Or if you've got one Vizz, which of these two Vizzes is similar to the first one? And if you just let people run with that, chances are they'll be dominated by their pre-attentive visual comparison, and they won't notice the text comparison. And how do you make the text comparison stand out in a way that you can kind of balance those two, or do you do the tests separately? Or, so it's just a big complication in terms of designing the user study for that. So let me go through a few concept screenshots of how we think this might fold into Tableau. The first one is basically a visual search by example. And just as your normal sort of Tableau today, you can click on any particular Viz in the display, and you'll get a little pop-up that tells you something about the Viz. And what we're proposing is that there could be a little button inside there that, for that particular Viz, show me some recommendations. And then it could go out and basically do something very similar to what our research prototype is doing, but with a nicer user interface. And it sort of folds in nicely with the recommendation button that's on the left panel as well. Another concept is to just completely integrate it into the current recommendation system so that it's just another thing that's added to the hybrid recommendations. And in that case, you click on something. In this case, it wouldn't be one of the trending ones probably, but if you clicked on a For You, the pop-up might come up, and when it says, why is this recommended, it might come back and say, it has both visual and topic similarity to your content. So it's a very almost invisible user interface, but behind that would be the same kind of content-based computations that would come up with a score that we could then add into the hybrid score that they're already computing for the collaborative filtering approach. And finally, one of the ones that I find the most intriguing is the idea of integrating it directly into authoring. So as you're building a Viz, there could be a little strip at the bottom that could actually show you other Vizzes that might be relevant to what it is you're constructing. And at a minimum, maybe give you some inspiration about, oh, I like that color scheme better, or, oh, I didn't realize that the bar graph could do that. And it could help you with your authoring process itself. But the best case is you're busy working on something and you realize somebody's already done this, and so you just stop what you're doing and pick that one. So there it is. That's the strip at the bottom. So what are the next steps? Well, we need to refine the content-based relevant algorithms further because clearly it's a complex thing. We're trying to develop what terms to extract from the XML, what technique is best for sort of computing the similarity, as I mentioned, how to break down this topic versus visual aspect of it. And we're making progress, but we still have a ways to go yet before we've really cracked that nut. We also need to think more about the profile creation, user profile creation, because we've been concentrating right now mostly on just computing the similarity. But we need to come up with a way to construct what it is we're going to compare between the user themselves and the corpus of workbooks that are out there in their repository. And so, as an example, some of the things we could do would be, for every workbook they have, go compute similarity to other workbooks and then kind of glom all that result together and rank it and then present it. Or maybe there's a way that we can take the workbooks that they have and aggregate them in some fashion. And do we want to do it based on the work they've created, or do we want to do it based on the work that they've created and the work that they've looked at, sort of in a almost collaborative filtering kind of way, but based on content, not just clicks and hits? And how do we weight all that? So that profile creation is still a step that we haven't really addressed too well yet, and we're starting to think about that. The key thing right now is trying to crack the nut of how to do the user studies, and we're still kind of up to our necks trying to figure out how to do that. And the main complication is what I was saying before in terms of the fact that there's these two perceptual tasks involved in doing this, and how do we construct something that fairly measures the two of those and compares the results. Ideally, what we like to do, which may or may not be possible, but what we hope to get to, is to be able to calculate our scores for similarity or relevance, and then capture users' impressions of what they think is similar or relevant, and then compare the computation with what they perceive and try to match those two together. But that's a really hard problem right now to figure out. Worst case is that we actually have to just do our best stab at it, deploy it, and measure the user interactions afterwards the way they have done for the deployment of the Tableau recommendation system. Anyway, so stay tuned, because there'll be more developments, and we hope to eventually publish some of this work, and it should be out, and you'll be able to see what we've been up to. So, you want to come back up? So in conclusion, as we mentioned, collaborative, am I still in? Yeah. Collaborative recommendations are available in 2019.4. And as I've described, research content-based recommendations and retrieval is underway, and we're trying to make good progress there. And these techniques can obviously be incorporated in Tableau in a variety of ways that can help users discover relevant content. So you can help. Please try the new recommendation system in 2019.4. It's out, you can go do that. And let us know, is the current system useful? Do you find it giving you reasonable content for your work? And can you suggest improvements? And tell us what you think. I'm particularly interested in what do you think relevance and similarity mean to you as it applies to visualizations and workbooks. And what kind of recommendation or search of this sort would you expect to see, and what would be useful to you? So please complete the session survey in the mobile app. You'll find it in the My Evaluations menu.